Good morning, everyone. This is your host Piyush Chandak, and today I welcome you to this industrial conclave with the title The Scope of Innovation in Electronic Sector for Aatma Nirbhar Bharat, organized by Institutions Innovation Council in association with IEEE Student Branch, Acropolis Institute. This industrial conclave is being conducted from 6th to 10th of October, and we have some amazing speakers who will be sharing their knowledge and understanding of the electronics sector for our students. As our speaker today, we have with us Mr. Pranay Wagle, Manager R&D at Nivo Controls Private Limited. Mr. Wagle is an accomplished professional with extensive experience of about 20 plus years in process control instrumentation, international certification standards, and project management. He has an in-depth knowledge of microcontroller-based technologies, analog design, and power supply systems. He is also an experienced designer and system integrator of embedded systems on microcontrollers, user interfaces, and HMI. He completed his DBM in Industrial Management from Vaishnav Institute of Management and Bachelor's in Electronics from Jivaji University. He also holds a diploma from SVP Indore. Sir, we are glad to have you amongst us today. Now, I would kindly request you to proceed with the session.
Thank you, Piyush, and good morning, respected teachers, all distinguished guests, dear students, and all the online viewers. Thank you, Team Acropolis, for giving me this opportunity to share my knowledge, to share my background, and share the things that we are doing as electronics engineer to support our country. There are three important words that Acropolis has given today. One is Atmanirbhar Bharat, second is innovation, and the third is electronics. So in the coming session, we'll be discussing all about these three words. So move forward to slide number 2. Today, we have three challenges in front of us because of this pandemic and other things: employment, economy, and then the third is Atmanirbhar Bharat. To go for Atmanirbhar Bharat, technologically, the solution is product development and innovation. These two words are important for me and important for all of us. Product development I have taken because we are electronic engineers. So basically this is related to electronic product development. Of course, other engineers are also welcome for this concept, and then innovation. Product development, I emphasize on 4 things. Your product should be reliable, means it's a long-term operational product with no faults. Your product should be rugged. You should have a very easy to use product. Cost effective, very important, because ultimately for economy, we have to fight for the cost with our competitors to have some competitive advantages. And safe to use. This word I included because whatever we do, whatever a product, whether it's for a child, it's for a lady, it's for a household, or it's for a mega engineering project, it should be safe to use. There should not be any unsafe things into it. So the product development essentially starts considering these 4 points in mind. Then comes the innovation part. What is innovation? Is creation, is development and implementation of new products, your process, your services, with aim to improve efficiency, aim to improve effectiveness, or having some competitive advantages. In a simple way, we can say, okay, it's successful, exploitation of ideas or new ideas. In coming slides, we will see what kind of innovations are there. It's not only the electronic products, it can be anything which is helping the society. And there are some successful exploitation of the ideas. Then I would like, and I am pleased to share some innovative ideas that we implemented in our products. So you can understand for electronics, what could be the different engineering sites where this innovation can be implemented. I move to slide 3. Remember, for innovation, you don't need a team. You don't need a developers or engineers teams or lab technician to be innovative. Anybody can be innovative. It's all about approach towards innovation. It's all about approach towards thinking. So today we have started with this thinking of innovation. And remember, it's not always an invention that brings the innovation. It can be your existing products also. Some of the best innovations come from reimagining your existing products or your existing services or finding new markets and applications. Same products you can use for different applications. Same products you can promote to different markets. So in an engineering industry, innovation could be, or innovation is, simplifying your products through development, through redesign, simplifying your processes. Could be assembly process or operational process. It should be very easy processes to assemble, make a product. Third one, very important, reducing cost. Cost is bound to have. The requirement is to reduce the cost so that your profits are increased. So that at the same time, you have to remember, while reducing the cost, do not compromise with the quality. Because you have to ultimately compete internationally. The fourth point that I added here is a product which is internationally sellable. Why internationally sellable? We want to make name of our country internationally. So all the products that we design, or we have, or we tend to redesign, should be designed in such a way that we can sell it in international markets. So innovation is improvement. This what I come to. Innovation is improvement. Any small improvement, any small innovation, any improvement which is giving value to your product is an innovation, which is ultimately will lead us to Aatma Bharat. I move to slide 4. This is interesting. I was talking about innovation is improvement. This picture I've taken from LinkedIn post. It says we have a word called jugaad in India. It's interesting. See, which means small yet powerful hacks, which transforms the productivity of an apparatus from ordinary to extraordinary. Ordinary to extraordinary. What you see in the figure here is a chappal. What is done is they have made some attachments to this. You can see the video is available on LinkedIn. Thank you very much, LinkedIn, for this video. It is given a certain attachment, the attachment of iron, and you can climb with this on the poles. It's very much interesting for the lineman of the electricity board, which is working, which has to climb on the poles without stairs. It's interesting. It has made their life very easy. So innovation is an approach. This innovative approach I like very much. I love this because this makes life simple. Anything which makes your life simple is innovation. Innovation can be from day-to-day life to any mega engineering project. This small, simple innovation has made life simple for a lineman. I'm moving to slide 5. This is another interesting thing. See, we know the water pumps. We need electricity. We need a line. We have to draw a line up to the well or up to the river to run the pump. This is interesting. What he did is a very simple thing. The handheld pump operated by a battery. This is interesting. This is simple. This will make life simple for the ladies who travel up to the river and then you have to put water into the bucket. You don't have to do anything. Simply sit at the shore, turn on the pump, and this will fill your bucket. So it's safe. It's safe. You don't have to enter in the water. You don't have to go inside the well or the river. It's interesting. This is amazing. I loved it. So these are kind of innovations that are going all around us. These two pictures are very much interesting. See, on the picture at left is the JCB, the interesting machine or heavy machinery. And the driver of this JCB is a Divyang. He is physically challenged. What his boss has done to it, he has made the operator's cabin automated. It can come down, it can go up, and it can sit. The cabin can sit in its place. The operator, of course, a skilled operator. That's why his boss has done this thing for him. He can sit with his tricycle in. Then the operator's cabin can go up to its place in the JCB machine, and he can operate the machine. Very interesting. So small household things to mega engineering project. Picture on the right, it's a very interesting innovation. It's very interesting innovation. See, the ladies from a village have to travel to river with a bucket on their head. It's very difficult. They have to carry a load of at least 20 kgs on their head. What is done here? They have made a drum of plastic. They have made a drum of plastic. These are recyclable, biodegradable plastics they have used. You go to river, fill that in, and carry those drums along with you. This have made life very simple for ladies of our villages. Interesting, very good. So these are the innovations. These are the innovations starting from day-to-day life, going towards the mega engineering projects. Now coming to our sector, electronics sector. I'm moving to slide number 7. The picture on the left, you can see, is a picture of charger of my laptop. You see, there are many things written onto it. Many things written. One is C, one is FCC. We don't even bother what is written and what does it mean. Let us discuss something which is related to electronics. All these are related to electronics, but the mark which we are familiar, you can see this mark on your mobile also. This is CE mark, CE mark. Just simple, a CE mark written. What does it mean? It means conformity European. Means a product declaration or confirmation to the directive, which is a quality directive without which you cannot sell your product in the European market. In Europe market, if you have to sell your product should carry a CE mark. And how this CE mark can be put? There are directives and standards. These directives are given by European unions, and there are different harmonized standards. There are different standards, lot of standards. There are literally a standard available for any product that you're trying to design or a design product. You have to comply to these products so that it can be put in the European market. Okay, a product which is internationally sellable, great. You can sell our product in Europe. You can sell it in India also. C never says putting C mark, you cannot sell your product in India. But we should be aware, what does it mean? What's the meaning of C? Oh, great. Now we can put our product in European market. Oh, let us see what else can we do. Oh, there is a US market available. We are discussing an internationally saleable product, what it needs. I was talking about standards. There are a lot many standards. We have to comply to the standards. There are IC standards. There are SANLEX standards. There are military standards. The MIL standards that we have to comply to the products if we want to sell our products to the forces. Then there are FM standards. FM mark is used for US market. Oh, great. This means I have to comply US standards to put my FM marks, or I have to comply to put a CE mark so that it can be put in European markets. Oh, different standards for same product. There are general safety standards, IEC 61010, this IC standard. Then there are EMC standard, IEC 61000 test standards applicable for the electronic products. Then the military standard, MIL 461E, this is EMC standard applicable for the products. There are environmental standards. And there are FM standard, FM 3810. Oh, these are different standards my product should comply to. Great. What is the opportunity? I'm moving to slide number 9. This is an innovative approach we have taken in our factory while designing the product. We wanted our product to be internationally sellable product. We want a CE mark, we wanted a FM mark on it. The requirement definition was we need to define a EMC filter. Oh, we are electronic engineers, we can do that. Okay. But it should comply to the standards of EMC, right? But it should comply to the standards for CE mark. It should comply to the standards of FM mark. What can I do? Okay, let us do. The product is same product will go to the European market and same product will go to the FM market, but it should comply. I cannot have different PCBs, but I can have a different circuit. I can have different circuit components, or keep the PCB layout same and put those components at a space which are different in values. So I don't have to maintain two different PCBs for two different certifications. I can do it with one PCB or with common inventory, cost reduction. Then there are different products I can make for different markets. Make a change in design of EMC filter. Your PCB or your product is ready for different marking on it, for different applications and for different international market. This we implemented very late. I think in 2009 we did that. This is a different approach. This is a different approach which is applied to a single product. Let us have another example. I move slide number 10. To conduct different EMC testing, different standards, we need different components, we need different test equipments, we need different methods. Or if I go for a certification from an agency like ERTL or agency like TVS or LRD Bangalore, the certification cost is very high. It's very, very high. But I need a certification. What I can do? Okay, let us have a test in-house. Let us make a thumb rule test in-house so that before putting the product onto the test agency, we are sure, okay, at least 10 out of 15 tests we have tested with a thumb rule inside. Oh, we don't have the available certification method, their standards, definition, everything, the test report. But at least we are confirming, okay, we are confirming the standard components, the standard specifications for this product. So what we decided, okay, we will, this line impedance stabilization network is used for conducting the conducted emission test for the products that we have. This MIL standard 461 is used for MIL standard 461E and other IC standards. The characteristics of the parameters that you are saying is important. We tried to establish it. We used our knowledge. We used the engineering knowledge. We designed ILISM. It's not a standard. It's not a standard mark, but it's a product which gives us the defined characteristics which we needed for conducting the conducted emission test. That's great. So what we did, we designed it ourselves. The LISM, which is available in the market at 75,000 rupees or plus, we could make it with 5,000 rupees. We designed this in 2006, and since then we have tested numerous products on it, and all these products are first time right from the test labs. So you can make some thumb rule methods. You are an engineer, you are taught to do that. Verify your design, put those thumb rule tests, verify your design, and then put those products to test lab. You will have first time right product going out of your design house. This gives you design confidence. No cost of failure at lab. If a product fails at laboratory, you have to pay twice. You have to give two times money for the certification cost. Your company will have some cost implications. It's interesting. I'm moving to slide number 11. The target here is reducing cost, common inventory, multiple products. All our products that we use in process control instrumentation are all products that we use at our house, our laptops, our TVs, our mobiles that operate at different power supplies. AC operated powers are required, which ranges from 85 volt AC to 280 volt AC. The DC operated voltages in the field or in the process control instrumentation operate from 18 volt DC to 48 volt DC, a very wide range. If I have to design a product which is to be used in field which has only DC power supplies, I need to go for DC designs, the products which are to be operated at 230 volt AC kind of voltages. I have to go for a product design which operates at AC designs, 85 volt AC to 280 volt AC. Interesting. The interesting is, what if I make a common circuit which operates from 18 volt DC to 48 volt DC on the same terminal. If I connect 85 volt AC to 280 volt DC, it will be a great thing. What I will achieve, a common circuit, a common product operating on AC and DC power supplies, a standardized input, a standardized output. When the output is standardized, same circuit I can use on different products. We have many common inventory. We have common specifications. We don't have to maintain two different products, a AC version and a DC version. It's all combined into one. Interesting. Very interesting approach. Advantages we see: cost-effective solution, very cost-effective solution. Common inventory. We don't need to maintain two different versions of same product. We can make it common for different products. Product A having same power supply circuit, product B having same power supply circuit. Product A and B can operate on any type of power supplies, AC or DC. We don't have to maintain 4 PCBs, 5 PCBs cannot be. With only one PCB, we can maintain different products. It's a common product for different applications. It's a common idea which can be implemented on different products. It's a common circuit, it's common components. We can reduce the cost simultaneously. We can compete with this kind of specifications with our competitor. US is operating at 110 volt AC, no need to worry. This product can work 85 volt AC or 280 up to 280 volt AC. Somewhere in process control, the supplies 24 volt DC, you don't need to worry about it. Same product can operate it. It's interesting. This is the innovative approach. This is the approach that is implemented in the power supply sector of the electronic engineering. Reducing cost, the objective. Common inventory is the objective. Use in multiple products is the objective. I'm moving now to slide number 12. It's a great thing. All our products, process control instrument products, are used in atmosphere, which is explosive gas atmosphere, explosive dust atmosphere. You are not allowed to open the product when it is energized. You can open the product in an unenergized condition. So what if I have to make some settings in the product, and that setting can only be done when product is energized? What to do? We have a concept that is non-contact keyboard. The push button keys, you can see on it. And there are non-contact keys that you can see. The Hall switch. The Hall effect is a switch you can activate with the help of a magnet. We use magnet to operate these Hall switches. Your product can be calibrated. Your product can be set without opening the cover or enclosure. Cover of the enclosure. It's great.
Sir,
Oh, hello.
excuse me, sir.
Yep.
Sir, there are some issues with your audio. If you could adjust your mic and check for the connection.
Yeah, it's okay now.
Yes, sir, it's better. There were some little issues with the audio, so.
Okay. Okay. Sorry for the audio disturbances.
Yes, sir, it's fine.
Yeah, fine. So we are on slide number 12. Reducing cost in multiple products, use in multiple products. Our products are mostly used in explosive gas atmosphere, are mostly used in explosive dust atmosphere. You are not allowed to open the product when it is operating in the field. You cannot make any changes. You cannot make any setting by opening the cover of this product. You have to do it without opening the cover. We designed a non-contact keyboard. It's a simple Hall effect switch, which is used as keys. So these keys are operated using a magnet without opening the cover. So all our environment is safe. Our product is not going to make any explosion in the use. It's interesting. All this keyboard, we can save at least 50% of the cost here. It can be used for different products. And this approach, this method, we implemented in year 2003. Let me move to slide number 13. This is a process improvement. What we discussed in was a product innovation. It's the processing innovation. We have to test 100 numbers of same product in a day. So we cannot make, if we want to make mains connections, we want to make the output connections, then we have to record the results. When we have to record the parameters, it takes a lot of time. We have to make the process very fast. We have to make process person independent. Anybody can do it. This is a PCB test setup. It's automated PCB test setup that we designed. This tests the product very fast. We could automate the test. We can generate the test reports later when all the testings are done. It records all the test parameters in it. It records all the things in a non-volatile memory. We take out that memory, connect it to a board, connect a printer, and take the printout of the report. We don't have to record all the things. We don't need skilled manpower here. We need a semi-skilled manpower who can do go-no-go testing along with recording of the parameters. Interesting, very fast, and you can have any semi-skilled person who can use this. Interesting. It does the things by itself. It has reduced the testing time considerably. It has automated. This is one of the examples that are how we do testings in the factory, in the industry. I'm on slide number 14. Your mobile has octa-core. Your mobile has 4 cores. Your mobile has 2 different microcontrollers. Your mobile has 14 microcontrollers, and then anything can be there inside. We did implement similar concept in year 2000, where we really wanted to reduce the burden on a microcontroller. Microcontroller is taking of everything. It has to display. It has to do A to D conversion, analog to digital conversion. It has to do digital to analog conversion. It has to do a communication on a network. It has to communicate with its master. Interesting. But this poor microcontroller has to handle all these things by itself. Then to have a fast response on 485 communication, we did a trick. We have used a separate single small microcontroller which takes care of the communication protocols, which takes care of all the fast controller thing. And our main microcontroller, it does the real-time thing. It does real-time data acquisition. It does real-time generation of alarms and everything. Interesting. We implemented this product in year 2000. Innovation opportunities are numerous. We have actually seen it can be design, it can be development, it can be production, it can be service. Not only software, not only hardware, not only firmware. Every electronics engineering operation has possibility, right from standards, right from analog electronics, digital electronics, embedded system, power supply, communication, you name anything, there is a possibility of innovation. There is a possibility of implementing things differently. There is a possibility of giving a solution to your customer in a cost-effective manner, reducing cost, simplify your process, reimagine your product, reimagine your process, reduce the cost product, and make a product which is internationally sellable. Innovation is improvement. Let me share 2 ideas that I have got. Actually, I prepared this slide this morning only. This was not there previously. The idea is to automatically detect the change of a hardware in a microcontroller by a master in RS485 multi-slave network. Some of the microcontrollers that come with individual serial numbering to represent a unique ID. Same as your IMEI, you can track where your mobile is. I can track where my microcontroller is. If somebody has changed the hardware, the PCB is removed, my master can track, oh yeah, this PCB is changed. This master has all the parameters programmed with this slave into it. It can reprogram the changed hardware. It will reduce the problems of your service engineer. This will become a plug-and-play product at your site. Interesting. Another interesting idea is a power supply which can switch itself off when there is no load connected to it. An interesting idea. My operators, they forget to switch off the power supply when they go for lunch. Similarly, in laboratories, students forget to switch off the power supply when they go for lunch or some kind of thing. What my power supply module can do, it will monitor the output. Oh, there is no load connected. Let me switch myself off. It can be switched on later. It will save at least some power. It will save power for half an hour, 1 hour power, maybe some watts, a few watts. But this few watts saved in a day can accumulate to hundreds of watts at the end of the month. This will give a very much cost saving on your running cost. These are the two interesting ideas I had this morning. Thank you very much for this conclave, dear friends at Acropolis. There is a chance in any part of electronics engineering you can do an innovation. Dhanyavad.
Thank you so much, sir. And I'm sure that all our participants would have learned key insights in terms of our electronics sector and how to approach innovation and contribute to our mission of Atmanirbhar Bharat. So I'm sure it was a very enlightening and informative session for all our audience. And moving forward with this session, I would like to begin with the question answers round. So we'll be selecting the questions posted in the chat box by our audience. So you are requested to post any kind of queries you want to ask to our speaker, Mr. Wagle, in the chat box. So, sir, should we begin with the question answers round?
Right. Sure.
Okay. So our first question is, sir, what do you think is the role of VLSI and embedded systems in the future of Atmanirbhar Bharat?
It's an interesting question. Embedded systems are everywhere. Even in your mobile, it's embedded system. Even in your alphanumeric display, it's embedded system. VLSI, in embedded system, you can make it generalized. VLSI, you can make the things very specific to a product. And designing a product, these are the future. Embedded system is the future. VLSI is the future. Power supply is the future. It's not only embedded system. It's not only VLSI. A product consists of a power supply, which is the heart of product. A power consists of a display, which is the eye. You can see things on it. So electronics is future. Embedded system is the future. VLSI is the future. Thank you.
Yes, sir. Our next question is, sir, how do we mitigate the low cost availability of electronics products and create more innovation? So it's about the availability of electronics products at very low cost in the international market. So how do we mitigate it?
That's why the innovation has come into picture, right?
Yes, sir.
If you are manufacturing a product, it takes some time to come out from your factory. That time consists of testing time. That time consists of assembling the PCBs. That time consists of the quality assurance time, the servicing time. All these times are associated with it. Of a simple example I would like to share with you. When we started designing embedded system, we started it with a microcontroller which was costing that time around 250 rupees. I was searching from new components, the new microcontrollers these days. are costing it 35 rupees to 100 rupees. So let us look into those products which are still having the microcontrollers of that age. Let us redesign that. Come out with the new components which are cost effective, which are very much cost effective and new. An important thing I would like to share with you. We had this company Microchip. It was manufacturing PIC microcontrollers.
Yes, sir.
And we had a company, Atmel Corporation. It was manufacturing microcontrollers like your 8 mega, what you have in Arduino, the tiny
Yes, sir.
series. Few years back, these two companies have merged together. And last 2 years, I am seeing the new components, the microcontrollers that are coming from Microchip are very interesting. It has a power capability, a micro power capability, which was there in PIC controllers, and expandability, the peripheral things which were there in the Arduino, this Atmel thing, are combined together. So the new
Yes, sir.
hybrid microcontroller is very interesting.
All right. So we'll take our next question. How can we generate better understanding of product standards as a beginning part of our journey? I think this question is more student specific.
Right.
So generating better
Interesting. Yeah.
understanding.
Interesting is like we have seen the example. I deliberately given that example to you so that the students at least start thinking of understanding what is it, what are the marks on it. That was the charger of your laptop. Just turn it around and you'll see lot many marks. Just put
Yes, sir.
those marks into Google. Google it out. You will find enormous information on it. For example, the CE mark that we put on process control instrument has got a product specific directive, which is given by the European Union. So every product has got a different kind of directive for a different product. Find out which directive is that. Find out the listed standards into that directive. Start studying those standards. And you will find ultimately these are nothing but the electronic test standards.
Yes, sir. So we just have to open our eyes and look around. We'll find
Yeah,
plenty of examples.
yes, find it out. It will be there on your mobile itself. There is a bucket and a cross onto it. What does it mean? You cannot throw your mobile into garbage box. It means
Yes,
that
sir.
waste of electrical and electronic equipment, how to handle the wastage, there is a standard for it. There is a directive for it. Government of India is working on it.
Okay. So our next question. VLSI fabrication in India is mostly done in ISRO. So how and when such fabrication processes will be made available to private companies of India for Aatma Bharat?
Government of India can answer this better than me.
Yes, sir.
It will come, definitely it is come, because if we have to see that, okay, semiconductor chips are to be manufactured in India, definitely our government is working on it.
Yes, sir.
Till then, we have to use available semiconductors which are cost effective.
Yes, sir. Um, the next question is future of electronic sector in India with respect to product development.
It's bright. I am designing electronic products since 1995. We are exporting our products which are manufactured in Indore to US, to Italy, to South
Yes,
Korea,
sir.
which are having different marks on it. These marks, CE marks, FM marks, these are tested. The FM marks, the tests for FM marks are done in US. The tests for CE marks are done at ERTL in India. So it's interesting. We are doing it. And we have a bright future for product development. It's interesting. I had been to your college last year. You have an innovation center over there.
Yes, sir.
I will request everyone of electronic engineers should utilize that. Think on it.
Yes, sir. Sure.
Find out different products and see how it can be. We can improve that products. It's interesting.
Yes, sir. Sure. Sir, I also had a question. So, like this would be our final question, and this question is very present with respect to the current situation. So, with the current COVID crisis, all of the production that was happening, electronic production that was majorly happening in China, is being shifted. So, and we are seeing that a lot of opportunities are available for India in terms of production, fabrication, manufacturing. So, what do you think is the scope, and how do we utilize this opportunity in the best possible manner?
This opportunity can be utilized by improving your skills.
Yes, sir.
With your engineering course, you get the knowledge, but you have to improve upon the knowledge so that you are skillful enough, so that the
Yes, sir.
industry can get things out of you, out of the fresh engineers. So I will request, or this is my suggestion to the young engineers, put on your knowledge on the practical things. Ultimately, you have to put your knowledge to design a product which will be practically used. So try to
Yes,
put,
sir.
try to attain practicals as many times as possible. Repeat the practicals. It's interesting you can do. And it's almost, I think, 25 years when I had the last theory class attended in my college. So the things had changed a lot. You got a lot of resources, lot many resources, lot many advanced resources. It's interesting. You people are lucky enough. You are working in latest technology, which is made available from your alma mater.
Yes, sir. Thank you so much. I would like to thank you once again for all your insights and for this wonderful session. And I would also like to invite Mr. Taksh Porwal for our vote of thanks.
Thank you, Piyush. So, a wise man once said, when you're out of quality, you're out of business. The way you talked about the standards and the innovations that we can give to a product was amazing. So, on the behalf of institutions, Innovation Council, Electronics and Communication Department, I would like to extend my heartfelt gratitude towards you for taking this session. It was informative and well received. Your presence made this industrial conclave a productive affair. So, thank you so much. And we wish you good luck for your future endeavors.
Thank you very much. Thank you,
And
Team
of
Electropolis,
course,
for
I
this
would like to
opportunity.
thank the attendees for attending the session. See Mr. Mudit Thakkar talk on one of the. Thank you, sir.
Thank you very much.
Thank you, sir.
Thank you. Bye
Thank
bye.
you so much.
Good day. All the best.
Mr. Mudit Thakkar. Thank you.